In this lesson, we shall talk about how to integrate an exponential function. So I have prepared a special video on how to differentiate an exponential function. In this one, we will talk about how to integrate an exponential function. Right, so when we were learning how to differentiate an exponential function of the form e raised to the power x, we said that the differential of e raised to the power x is the same as e raised to the power x. So since nothing changes when you are integrating it, that is when you are going back, nothing changes. Okay, so the first rule I want you to put in mind is that when you integrate e raised to the power x, the answer is e raised to the power x, okay, plus a certain constant c. Okay, now another record. When you are given an exponential function such as e raised to the power ax plus b and you are to differentiate, we said that you keep the function, okay, you keep the function. All that you need to do is to differentiate the exponent, and when you differentiate this, you get a. All right, so this could be said that a is multiplying the exponential function, isn't it? So what happens with the integration is the opposite. We will not multiply, but we will rather divide. Okay, so this is it. So when you are to integrate an exponential function, all that you need to do is to use this a as a denominator and you are done. Okay, but if it is an indefinite integral, then please remember to bring the plus c. All right, it is really important. So now let's practice our first example. We have e raised to the power 5x and we want to integrate this. So like I said, it's the same e raised to the power 5x, okay, but you divide by the coefficient here, that is 5. All right, so that is it. You are done. Very simple. Okay, how about this? So we deal with the coefficient of the x term, okay, that is what we deal with. So you keep the entire exponential function, then you divide by the coefficient, and that is -2. Please be careful, the negative must show, okay, so you divide by -2. It's the same as you saying that -half times. I like to write it this way, but of course you can also write e raised to the power 5 minus 2x all divided by -2. That is also fine. Then we have this. So this is like a product. Of course, you have e raised to the power x, and then you have 5 minus e raised to the power x. 2x. They are multiplying, which is fine. So the first thing you do is to expand this bracket. So let's do that. We will expand, and now when we expand, we have 5 e raised to the power x. Then remember, this is e raised to the power 2x, this is e raised to the power x, so they add up to become e raised to the power 3x. Then we can integrate. All right, so when we are integrating it, like we came up with e raised to the power x, when you integrate that, is the same as e raised to the power x. Okay, now this is 3, okay, so that has to come and divide, and you are done. All right, really simple. Then we have this. What do? We can open this bracket, okay, so let's open it up. When we do that, all right, when we do that, we have 9 e raised to the power 2x plus 6 plus e raised to the power -2x. Okay, I believe you can open this bracket. All right, so this same thing multiplies by itself. All right, okay, then we integrate. So remember this 9, we have e raised to the power 2x, so these two come and divide. Now 6 is there, we are integrating with respect to x, that's why we have dx, so that becomes 6x. When you integrate a constant, you get a function. Okay, Then this is -2, so we divide by -2. Then you clean this up and then you are done. All right, so this still remains, that remains, but this is -2, okay? So it changes the negative sign here, all right? And then plus C. Of course, someone might want to write this as 4.5 and this as negative 0.5. That's also fine. How about if we are given something like this, right? So since 3x squared e raised to the power 2x and then 4 e raised to the power x share the same denominator, it is common to both, okay? So you can divide, you can really simplify, okay? So if you have something like this, like I said, it is common to both. So you split, this is here and the same as that. So all that we have to do is to cancel out. X squared will take care of x squared, all right? Then 3 will take care of 12, okay? 3 goes here once, goes there 4. And then this is e raised to the power 2x, which means it's double of this. So we can use e raised to the power x to cancel one of it, okay? So that to be left with e raised to the power x. Then this will take care of that 4, and then 12 will also work. So let's see. Now when we try, the 3 will divide the 12, so we have 4, but the x squared will go away and this will take care of that, so we have a remainder of e to the power x. Then 4 will go into 12 3 times, e raised to the power x will cancel e raised to the power x, so we are left with 3x squared. All right, so now that we have this, we can rewrite this, okay, by use of indices, so that the x squared becomes x raised to the power -2, okay, because it was a denominator, right? So from this angle we can easily integrate. Now when you integrate e to the power x, you get the same as e to the power x. So in a way, this is like 1/4 of e to the power x. Then -1/3, we keep it. Then we will add +1. Okay, so that will be -1. Then we divide by -1. All right. Don't forget the plus c is really important, since there is no lower and upper limits. Right, so the same thing is what I have repeated here for us. Okay, so what happens is that this negative times that negative will become positive, all right? And then since this is x raised to the power -1, it comes down here and then we are done.